All right, and if you haven't figured out by now, we are going to be talking about functions a lot this year. A piecewise function is defined using multiple equations. So defined multiple equations. And those multiple equations are used for different intervals. And we'll see what that means in just a second. So here's an example of a piecewise function. It says that f of x equals x plus 1 when x is less than 1, and f of x equals x minus 1 when x is greater than or equal to 1. So if we look over at the graph, this is our x-axis. So moving along here, when x is less than 1, we use x plus 1 as our function. So for all of this part of the graph, when x is less than 1, we're using f of x equals x plus 1. Now, when x is greater than or equal to 1, so that means from here on to infinity, we're going to use x minus 1 as our function. And so we're going to take a look at how do we graph these, how do we work with them. And it's not very difficult. You just have to pick points that are within this interval. So any number x less than 1 means we're going from negative infinity to 1, but we don't include 1. And x greater than or equal to 1 means we are going to start at exactly 1 and include it, and we're going to go to positive infinity. So hopefully you remember from our domain and range that this is what we're doing. We're still going from negative infinity to positive infinity. It's just we're going to change at 1 how this graph looks and what it does. So start real quick and pick some values. And let's start with picking values that are all less than 1, because it tells us we need to do stuff that's less than 1. So we'll pick negative 2, negative 1, and 0. And we just plug them in. So negative 2 plugged in. Remember, it gets plugged into here because negative 2 is less than 1. So negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0, and 0 plus 1 is 1. And we can translate that over to the graph. We can find this point. So negative 2, negative 1 is right there on the graph. Negative 1, 0, already on the graph for us, and 0, 1 is our y-intercept right there. Now let's plug in some values that are greater than or equal to 1. Well, of course we should start with 1 because it says equal to 1. And then we'll do 2 and 3. So when we plug in a 1, which is greater than or equal to 1, so we need to use this equation, we get 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 1 is 2. So we look over here, we have 1, 0, 2, 1, and 3, 2 right on our graph. So that's a piecewise function, and that's how we graph it. And we can see here that our piecewise function, if we're doing the domain of it, goes from negative infinity to 1, but then it starts right back up again at 1 and goes to infinity. So we wouldn't say that our domain has any kind of break here. We would just say that the domain of this function is from negative infinity to positive infinity. So we wouldn't write it that way. We would just write it this way. All right, so let's go down and take a look at another one. So we have f of x equals 3x minus 1 when x is less than or equal to 1, and f of x equals negative 2x plus 2 when x is greater than 1. So we're just going to do what we did up there. It says evaluate the function when x is 0, 1, and 3, and graph it. So let's start with f of 0. Well, 0 is less than or equal to 1, so we're going to use this function. So we plug in a 0, 3 times 0 is 0, minus 1, we get negative 1. Now we're going to use f of 1. We'll see 1 is equal to 1, so we're still going to use that one again. So plug in a 1, 3 times 1 is 3, minus 1 is 2. And then the last one, it says f of 3. Well, 3 is not less than or equal to 1, it's greater than 1. So we're going to use this equation for 3. So negative 2 times 3 is negative 6, plus 2 is negative 4. And I want to go ahead and pick some other points because that's not really enough points to make a good graph. So we're going to use our x's less than or equal to 1 points, and then we're going to do some x is greater than 1 points. So less than or equal to 1. We can do negative 1, negative 2, negative 3, any numbers we want that are less than or equal to 1. And we already did 0, so we don't need to do it again. We've already done 1. So let's use negative 1. So negative 1 times 3 is negative 3, minus 1 is negative 4. Negative 2 times 3 is negative 6, minus 1 is negative 7. And then negative 3 times 3 is negative 9, minus 1, negative 10. So now we've got some good points here. So let's plot those points. Negative 1, negative 4 right there, negative 2, negative 7, and then negative 3, negative 10 right there. And we also have 0 and negative 1, so we know that's a point. And we have 1, 2, so 1, 2, also a point. All right, now we need to do some other points, some greater than 1 points. So we've already done 3, and we can't do 1 because it's not greater than 1, so let's do 2. We already did 3, 4, and 5. So just plug them in. 2 times negative 2 is negative 4, plus 2, negative 2. 4 times negative 2 is negative 8, plus 2 is negative 6. And 5 times negative 2, negative 10 plus 2 is negative 8. So we're going to put these points on our graph now. So 2, negative 2. 2, negative 2. And then we have 1, 2, 3, 4, negative 6. Then we have 5, negative 8. And we also can't forget about our 3, negative 4. So 3, negative 4. So it looks like we have 2 lines, or at least 2 pieces of lines. And to decide how we need to finish them off and how they're going to look, you go back up here and realize that at this point right here, where x equals 1, this graph changes from our red 3x minus 1 to our blue negative 2x plus 2. We're going to have to go ahead and extend this line up to x equals 1, but instead of putting a 1 or putting a dot there, we're going to put an open circle. So when we graph these, we have our less than or equal to 1 values, and we have our greater than or equal to 1 values. Notice that we have a hole on this one where x equals 1 because x can't equal 1 on this graph, but it can go all the way up to it. So we go from negative infinity to 1, include 1 right here, and then we start right back up at 1 again, but we don't include it and go to positive infinity. So again, that's what's happening, but our domain is actually negative infinity to infinity because there's nowhere in this graph that we don't include the 1. Alright, so one more to do. And I think the best thing would be for you to go ahead and do this one yourself. Just give it a try. I'll go ahead and give you one little tip here. Realize that when it says x equals 1, this is 1 point, and that's it. Okay, so there's not going to be much except 1 point when x equals 1. And then you need to go ahead and do when x is less than 1, when x is greater than 1. Each of these values get you some points, put them on the graph, and let's see what this thing looks like. And we will check it out tomorrow.